Hey Math 1, welcome back. I don't know if it's going to keep working, so I'm just going to jump in and finish the example I was working on from part 1. So 1, -1 would be this point right here. 2, 1 will be this point here. All right, 5 points is generally enough to get a nice, neat line. But if you want to, you can just say to yourself, hey, I see the pattern. Up 2, right 1, up 2, right 1, up 2, right 1. And you can kind of say, in addition to the table of values, you can plot more points. Up 2, right 1, up 2, right 1. And that's okay as well. I just need to see the table of values filled out. So it's just an alternate strategy. Bada bing, bada boom. Okay, I have 2 more examples here just to kind of show you what to do in strange situations. So what I mean by strange situations are, all right, so here I'm going to start in the middle, but it says we're going to skip count by 5. And here's the deal with skip counting by 5. If I skip count by 5, 5, 10, I'm like off the chart already. So what I wanted to do is give you guys something in your back pocket to go to if you ever needed to plot more than 3 points. So 0 is certainly going to be my middle point, but instead of skip counting by 5 and 10, I'm going to say put 5 all the way on the end here and put 5 all the way on the end here. There's an extra box there, didn't mean to do that. And then I'll show you guys what to do beyond that. So first things first, let's plot these 3 points. So if you plug in 0 here, 0 times 4/5 is going to be 0 plus 3 is 3. So I've got the point 0, 3 to start this thing out. The 5s here will cross cancel with the denominator of your fraction. So 4/5 times 5 over 1 plus 3. That 5 divided by 5 is going to be 1 over 1. 4 over 1 is 4 plus 3 is 7. So 1, 2, 3, 4, 5 up 7 is going to be that ordered pair plotted. This one right here, if you try it out, is going to be 4 over 5 times -5 over 1 plus 3. The 5s cross cancel again, but in this case you get -1. -1 times 4 is -4 plus 3, -1. So you're going to go left 5, down 1. So if we need to fill out this chart here, what I would encourage you guys to do is think about how the rate of change is 4/5, okay? And you guys are going to see this on a later lesson too. The rate of change 4/5 is the exact same rate of change as 4 divided by 2 over 5 divided by 2. Okay? It's very strange what I'm talking about right now. But it can be helpful in these situations where there's too much space between. 4 divided by 2 is 2. 5 divided by 2 is 2.5. So what you can do, okay, to fill out the rest of the table is say, hey, let's hop by 2.5s for the x's. Okay? And go 2.5 in the other direction. I just took half of 5. And now what that does is I don't even need to plug these values into the actual equation. What I can do now is take one of my points. Okay, there's the 0, 3. All right? I'm going to go up 2 units. Okay? Up 2 units. And then go right 2.5. Right 1, 2, and then go 0.5 units in. So it's between a block there. And then I'll just do the same thing from this point over here. So it's 2.5, comma, 1, 2, 0.5, up 1, 2, 3, 4, 5. So see, the pattern persists. You got to skip count. Plus 2, plus 2. Above, plus 2.5, plus 2.5. So -1 plus 2 is 1. Plus 2 is 3. Plus 2 is 5. So it's actually -2.5, left 1, 2.5, comma, positive 1. All right, so that fills out the table, and here are our points. All right, last example. What are you supposed to do if you've got two fractions? Well, just visualize this as the significant fraction is the negative 1/3 x because it's the m, okay? The 7/5 fraction is more so, let's make sure we put that as a mixed number or a decimal, because that's going to be the place that doesn't negotiate rates of change, okay? So I'm still going to start in the middle here. Let's see, skip counting by threes is okay because it keeps us on the grid. At least it seems to keep us on the grid so far. I'm skip counting by threes because the denominator of my slope is 3. All right, now if I plug in 0 right here, 0 times negative 1/3 is 0 plus 1 2/5 is 1 2/5. So your first point's going to be right here, just below 1.5. Second point, y equals negative 1/3 times 3/1 plus 1 2/5. That's going to be negative 1 plus 1 2/5. What's the difference between 1 and 1 2/5? 2/5. Okay, so you're going to go right 3 units, up 2/5 of a unit. Interesting. See if we can establish a little pattern here. Negative 1/3 times 6/1. The 6 and the 3 cross cancel to give us 2/1. That's going to be negative 2 plus 1 2/5. So let's see. The difference between negative, see, opposites subtract, so you're subtracting the two. 1 2/5, 1 3/5, 1 4/5, 1 5/5 is 2. There's 3/5 difference. And the bigger number is negative, so it's going to be negative 3/5. Over 1, 2, 3, 4, 5, 6, because the x is 6, down negative 3/5. All right, I don't know if you guys are seeing this, but it means jump 1. Jump 1. This should be jump 1. Let's confirm that. Y equals negative 1/3 x, which is negative 3 now, plus 1 2/5. A negative times a negative makes a positive. Cross-canceling, you get 1 times 1 is 1 plus 1 2/5. 1 plus 1 is 2. The pattern continues. So I just got to go left 1, 2, 3, up 1, 2, and 2/5. And then this last one, jump up 1, jump up 1, jump up 1, jump up 1. So left 6, up 3 and 2/5. 5, 6, up 1, 2, 3, and 2/5. All right, so at any rate, this gives you guys just a new look at how to graph linear equations using a table of values. I'm not saying it's going to be your preferred method. It's not my preferred method, but it does teach us a little bit more about the patterns that go on with linear equations. And I think spending just one day on it will be helpful. If not now for this chapter, I think it'll be helpful in the future. All right, thanks for staying with me through the technical difficulties. Good luck on the assignment tonight.